I'm Carl Bateman. I'm a self-appointed WebGL evangelist. I started doing it a couple of years ago, and I think it's the best thing since sliced bread. I used to do OpenGL, but WebGL is a lot simpler for setup and coding. And of course, since it's on the browser, it's out there straight away. You're not messing around trying to build or do installs. Yep, I love to code. I love graphics. I love mathematics. So things like you can't really. I do apologise. The resolution on this is a bit wonky. Quite low resolution. No, I can't make any better than that. Can I read that? So it's e to the pi I plus 1 equals 0, and I squared is equal j squared equal k squared equals ijk equals minus 1. Now that's my idea of fun. That's actually quaternion. That's the Euler identity. I also love the internet and web coding. Actually, there's a bit missing there, you can't see. The point is that I tend to come from this from a mathematical, geometrical, programming point of view rather than a web design point of view. So I might approach things from a slightly different perspective than you might be happy with. But yeah, if you have any questions, do ask. So I find that WebGL is a nice intersection of maths, computer graphics and coding, so it's a sweet spot for me. Oh, sorry. Come in, be quiet, it's all right. Yeah. So as you can see, there's a massive intersection between those three areas with the WebGL. It's actually quite deceptive. There's a lot more involved with WebGL than that might actually make you think. Yeah, I set up the workshop because it's easier to ask somebody than it is to Google. I always find Googling can get you results, but they're not necessarily easy to understand. Yeah, we're sponsored. We've got free pizza. We've got beer. Blah blah. That's not really relevant to what we're talking about today. So, the agenda tonight, I'm going to talk about Cronus very briefly, explain what WebGL is, bright light. So what is WebGL for you? Is it something you can use? WebGL in the wild, that's going to be some examples of WebGL out there in the real world being used for various things. WebGL for fun and profit, I'm just going to quickly do some code to actually show you how you actually do it in some code. And then a few demos. Hopefully a lot of demos, but we'll see how we are for time. Yeah, please, I don't know if this is true, David minds this, but as far as I'm concerned, go mad, take photographs. Please feel free to tweet if you want to. Hashtag WebGL Workshop. And please do ask questions, that's the whole point as far as I'm concerned. Don't worry about interrupting me, as long as I can see you in the murk. I'll try to answer any questions you have. Better to ask it when it occurs to you, even if I say I'll answer that later, rather than trying to wait later and forgetting what you wanted to ask me. Right, Cronus. Cronus is a consortium, about 100 members worldwide, including things like Microsoft, Apple, and so on, who are responsible for a bunch of standards, including WebGL, also OpenGL, Vulkan, some people may have heard of it, and some others. So it's a worldwide standard, so that means it allows you to access the graphics facilities on a GPU on any device. So we've got over 1 billion people use Cronus APIs, and so that's so it allows you to have 3D on over 2 billion devices worldwide, probably more by now. This is all data. So basically WebGL is OpenGL ES2 for the web. ES2 stands for embedded system, so it's actually intended for on the chip, embedded devices, things like phones. That is the definition from Cronus. You're welcome to go online and read that, but I'll just do a quick summary, hopefully it'll be a bit quicker. It's canvas-based, it's a JavaScript API, so it's standard. It's on, if you've got JavaScript on your machine, it should have the WebGL API implemented. It gives you access to the GPU from the browser. It's part of the web standards, so it's available on all devices and browsers, as it should be. So that's including Apple, including Microsoft Windows, or everything. And it allows you to render to 2D and 3D. Even though it's just a render rasterizer, it can actually be bent to our will, so you can do other things as well. Image processing is an obvious thing. It lends itself naturally to. You can do things like ray tracing and volumetric rendering, but it's not really intended for things like that, and it is actually a bit of a corruption what it's intended for. You can do it, but it's a pain. So a bit more detail about WebGL. One of the key points of WebGL is a thing called a shader program. Now hopefully this actually gives you some idea of what that is. It is a bit blanched out, isn't it, I'm afraid. So you have your browser down here on the right with your JavaScript. What you then do is you write a GLSL program using the GLSL language, and that's a separate program that is compiled within the browser and put on the GPU and run. So you've got your JavaScript app, whatever, and then you actually have an app on the GPU, and the two have to talk. So there's actually a way to communicate data to and from the GPU. It's never a good idea to read data back from the GPU because it's very, very slow. You want to have as few calls as possible. The shader program consists of a vertex shader and a fragment shader. Every single shader program has to have a vertex shader and has to have a fragment shader. What happens is the data is sent to either the shader program and or the fragment shader. Usually this is the vertices of the object you want to display in 3D. It doesn't have to be, there are other things you can use. That data is then interpolated and passed to the fragment shader and then displayed, essentially. So the data you would send to the fragment shader might well be things like textures or colours that you want to actually implement, or possibly the position of a light. But you can pass data to either of those two shaders depending on the amount of processing you're happy to do on your device. One of the interesting aspects of this is because it is browser-based, your code might be running on any device. It could be a laptop, it could be a phone, it could be a tablet. So you do have to take into account things like energy consumption. So even though the code will happily run on everything, it might murder the performance on a particular device. So you have to experiment with it. That's just one of the gotchas you have to watch out for. The shader program is actually compiled and run on the GPU. It is a separate XE. It will be as fast as native code because that's what it is. Essentially, it's native code running on the GPU. So even though the JavaScript might be slow, the WebGL program, the GLSL program will be fast. I think they said around about 50, it averages around about 50% the actual native code. Are you all happy with what a shader program is? I did one of these in the past and people just didn't get what a shader program was. It's actually a key thing. I'm just used to it because I've done it for so long and now know what a shader program is. It's one of these key concepts that you get used to over time. No dissenting voices, I will move on. Sorry, yes, please do ask. Say again?
Could you explain it, what is it? Because right now I understand that WebGL application is written purely in JavaScript, but looks like I have a wrong perception of it.
No, it's right. It's actually right. I will actually explain more in detail. I've actually got some code where we actually do write a shader program. We will compile it and we'll do it from the JavaScript. Yeah. So you're actually in the right area. You're actually right. It's a separate program that is compiled within the JavaScript. Your JavaScript program will compile a GLSL program. Yeah. Right. So yes, it's on the GPU. So as long as it's written correctly, you're going to have parallel processing. It's going to be it's going to be very fast and it's very flexible. The downside is you got great power but great responsibility. You have to understand basic geometry if you're going to do any 3D or anything like that, any image processing. You have to know the underlying code unless you use an API or library, because basically you're left on your own, which is a bit of a shock if you're used to things like the area OpenGL, which used to have a lot of things to help you. Excuse that, but let's see. There we go. An example now. On the left, this is written in JavaScript. This is actually a WebGL program, GLSL, just to give you an idea of the speed. So I'm going to click on there to zoom in. There we are, a bit slow. Do it on here. Click on that. Whoops. You see it's a lot quicker. Actually zooming in. So that's probably in the order of 10 times faster. So that's one of the main reasons for using GLSL, or WebGL. It's a heck of a lot faster. Actually, I think because of this is not plugged into the main, it's running a bit slower than usual. Usually the difference isn't quite as marked as that. But one of the main reasons, this actually also, I do apologise, is a bit jumpy. It's a work in progress, I haven't quite finished it yet. But the basic takeaway is that running things on the GPU is a lot faster. Okay, some examples. There, in the top left. It's very jerky on my computer because it's not plugged into the mains. So again, that's just a bit of site decoration. That's a bit of WebGL in the top corner. Let's make it look a bit prettier. Try that one. So in the background, you've got all these cubes. Again, that's WebGL. And again, cubes. Cubes seem to be a favourite. So cubes. This one's a good one. This is quite an impressive one. I'm going to show this 3D animation. Again, it's WebGL. And this is actually 3D, so if you want to, you can interact with it. There's actually a video with some music tied in with that, so if you press the play button, which I won't do now, I'll do something a bit different. Oh, yeah, this one's good. This one's that's actually a screensaver for a phone, but again, written in WebGL. So that's quite an intense use of GPU there.
Not a battery saver, though.
Oh, almost certainly not, unless it's been optimised, which is not impossible. So it probably does murder your phone. So yeah, it's a screensaver, but not a battery saver. This is actually a WebGL presentation layer. Sorry, not layer. Sorry, presentation platform like PowerPoint or whatever. And it actually is 3D, and you can actually edit it and interact with it. So that's good and fun. But I tried to use that, but it's a bit awkward to use, I found. Yeah, I'll move on because I want to try to get through things as quickly as possible. So I've got a lot to cover. So is WebGL for you? So basically, you need to find out if it's going to work on your computer. It should do, and also which features are available. The basic features should be available. Some are a bit iffy. Sometimes the number of shaders or number of variables available within a shader can be low, which is bizarre. The number of textures you can use at any one time. Again, technical stuff, it may not mean anything to you. I'm sorry if I get too technical. But get WebGL's interesting, because if you go to that website and you don't get a cube spinning, you can't use WebGL. It's not on your browser or your machine, which would be very, very odd these days. So this is a good one. It tells you things. Well, does your browser support WebGL? Yes. Is it enabled? Yes. WebGL 2 is coming down the pipeline. It's I think there are switches you can set in some builds of WebGL, possibly Mozilla Firefox, that allow you to use it, but it's not going to go into it just at the moment. Then you have things like the maximum number of vertex attributes and so on and so forth. But yes, there's a whole bunch there you can actually go to. WebGL stats is the actual number of machines using WebGL that go to a particular site and records use, general use. Right, moving on. Code time. Yes, let's look at a bit of code, which I mentioned before. This is actually just really teaching code, which I use. So you start off with the basic. Oh, you can't read that, can you? I do apologise. I have no control over this. Can you read that? Is that readable? Okay. So this is a single web page, which obviously in real life you could break up. So you could, so you've got your scripts here, which are going to be your fragment shader and your vertex shader, which you're going to compile into a single shader program, and then you'd have your script here, for example. Obviously, you could break that up any way you want to. You could load these using an XML HTTP request if you wanted to, and that you could just do as a separate JavaScript file if you so desired. It's just a lot easier to do it this way. They have a script ID vertex. It has no meaning to the HTML JavaScript. It just treats it as a script. If you try to load one from an external file, it won't like it at all. It'll just treat it as a null node. I'll explain that a bit later. It's just a lot easier to do it this way because it's in a single file, so it's easier to jump around. Right, so there's that one. So we then actually fill it. So these are pretty much the simplest shaders you can do. All this does is take a position, you pass in a position from your JavaScript, and then it sets this thing called GL position. That's an internal variable, which is the actual location of your vertex, which is an output to be rendered. And then the fragment shader, in this case, we're just passing in a colour. Fragment is essentially a pixel, so it works for all the pixels on the screen, and it assigns that colour to that pixel. What actually happens is for a set of positions, depending on how you tell it, you can tell it to points, lines, triangles, etc. It will interpolate that data. So if you tell it it's a triangle, you give it 3 points, it'll fill them in, essentially, and interpolate the vertices, so it knows where they are, and then actually rasterize them, so then it fills them all in.
You haven't defined the color, have you?
Not yet, I haven't got that far. This is here, it's the colour.
But it's not actually, there's no value there yet.
No, I'm going to pass that in. We got this thing called the uniform, which means it's not going to change over the life of the shader, but we're going to pass that value in from the from JavaScript in a second. Sorry.
Does WebGL see them as proper things in scripts, or
No.
does it just
No, this is
count
just
them as a string?
that's just a string.
Okay.
These are placeholders within a string. They're going to be taken and compiled by the
Okay.
compiler separately. JavaScript doesn't understand these at all. If you take up, well, no, yeah, if you try to run them, it's going to go, what the? It's going to give you an error. So it is not JavaScript. This is GLSL. JavaScript is untyped. You can see these are actually typed. So it's uniform. It's about 4. It turns the precision. And anybody here familiar with C, C++, some languages? So you've actually got a void and a void main, which you don't have in JavaScript at all. You have something similar in Java, obviously. Obviously C++, so it's a C++, a true C++ type language. JavaScript looks like it, but it's actually just what I call a curly brace language, which is sort of similar, but not quite the same. So you have a bit of a friction between the two. So you've got untyped and typed languages, but that's a different issue. Right, so those are the, just go back up again, sorry. Yeah, so those are the shaders that we're going to be using later on. They're inside the script tags, so they're not going to be used in any way, shape or form. They're just strings as far as the JavaScript's concerned, web page is concerned. Right, so within the JavaScript itself, first thing we do is create a context. So we tell it whether, I don't know if you've done the 2D, it's the same sort of thing, except we tell it it's going to be WebGL or experimental WebGL or WebKit 3D or Moz WebGL. Most now support WebGL, but you can use all 4 if you want to, in case one fails and one of the other works. If you've got an older browser, you may want to do that. I think if you go before Internet Explorer 9, it won't work. Right, so once you've done that, you then error check. I actually think that's out of order. That should be done after the compilation by looking at it. I think I do. Yeah, I do apologise. I've got that stuff out of sequence. But you do that a bit later. But one thing you need to do is whenever you do something, you need to start error checking because things can fail, and if you don't check it, you're going to wonder where things have gone wrong. Right. So this is the boring bit. So you have to build, compile, link, and use the shader. So at the top, as I said, we're getting the element by ID, the vertex and fragment shaders, first child, no value. Hopefully your JavaScript's good enough to understand what's going on there. Those are just essentially those 2 chunks of code as strings. Again, no special meaning as far as Java is concerned. So we create a shader, you tell it what the shader source is, and then you compile it, and then you do the same for the fragment shader. You then create a program. It's boring, I know. Attach the shaders, link the program, more error checking, and you should do the other checking too. If all that passes, then we use the program. Fun, fun, fun. Right, you were asking about, sorry, go on. Sorry again?
Compiling and linking on the device. Is it done? How quick is it?
Usually pretty quick.
Okay.
It doesn't take that long.
It takes some, but it compiles. So the browser is actually the browser compiler is compiling this one.
Yes, the JavaScript's doing it. Yeah, and I've never had any problems with the compilation. I mean, even let me see, because generally speaking, it's only a short section of code anyway, a few lines anyway. Even mega big shader programs that I've seen don't take that long to compile.
Okay.
So usually it's...
Safe.
Yeah, it should be safe. There was a big stink 2 years ago. One of the reasons Microsoft refused to accept it was they said it's not safe. But people pointed out that Windows Presentation Foundation was actually just as unsafe as WebGL, and they changed their minds ultimately. I think if you try, I know people have tried really hard to break it and cheat and whatever, but I think it's pretty safe. I was thinking, 'cause you have things like cores now as well, take care of a lot of things. So I don't know. Again, I'm not a security expert. I don't know the details. I just know it's safe now, or relatively safe, as it can be.
That's safe in terms of it can't break into your own.
I'm assuming she's talking about hacking. Yeah.
I mean,
You won't get
could use
buffer
some
overflow or anything like
strange,
that.
Sending out spam or whatever, having some.
Yeah, somebody asked me if they could set it up so they could do set up a Bitcoin miner.
Oh, right. Oh, that'd be-
I don't think you could actually, because it's not going to be able to. The WebGL program will not be able to communicate with the outside world, and if it did, it'd be ridiculously slow. I think so. I think it's impractical. WebCL is a different method entirely. Sorry.
Could it do it via the JavaScript instead of a Bitcoin miner where you have a JavaScript?
Yeah, but you won't have to run it on the WebGL, I don't think. I don't know the details. I don't want to get into that because I'm not a Bitcoin expert. I'm not a security expert. Right, so, yeah, data location. So you're asking about setting the colour. So we're actually getting, if you remember, it was U colour. That was actually the uniform location. Sorry, the uniform value in that code. So we've compiled it. So the program now actually has a uniform called uColor, so we get the uniform location and assign it to that. That is, I'm actually adding that property to this object as I go along. It's not something that's natively part of that. It's one of the nice things like about JavaScript, you can change objects on the fly. And then we have a vertex position. Now this is actually what's called an attribute as opposed to a uniform, so it's slightly different. Again, we give it the name of the variable within the shader program, and it gets it for us. So we now know those locations within the program, so we can actually assign the values. We then need to actually enable the vertex array. Because uniforms are easy; you can send values straight through. Attributes are a bit more complicated. You have to actually enable them because you have different types of attributes. Right. So we've now got the locations of the variables within the program. That allows us to write data to the program. So the next thing is we need some data to send to the program. So we're going to just draw a triangle, two-dimensional triangle. So we have 3 points, x, y, x, y, x, y. Now remember I was talking about this friction between untyped and typed. So we now actually have some types within JavaScript. So we actually convert these untyped values to typed values. So an array of float 32. If you try to send through an ordinary array, it won't like it because it's actually an array object, and all hell will break loose and it just doesn't work, or you get something that works funny. So you have to actually convert it. You can either do it separately or in one hit, as long as the value has been sent through with actually a float array. You also can do this with ints. I think for colours you use ints. And the different types of arrays that are supported within JavaScript. Right, that's actually incorrectly named. It says Q vertex position buffer. It's actually triangles. So we create a buffer, we bind the buffer. It's fun, isn't it? All this malarkey you have to do. Then you assign the buffer data. Then you have to make a note of the size for this part here, and then you actually the number of items you're going to send. So in this case, we've got 6 items within the array. However, each one consists of 2 items itself, an x and a y. So we divide the length by the number of items, and that will give us 3. 6 divided by 2 is 3. That's at this point, it doesn't do anything. It's something we're going to pass into it later. Right, so we're now going to send the data to the GPU. That's when we need to know how many items we have. So the uniforms, as I said, it's really straightforward. So we know the position, and we're writing that value to it. Oh, it's a 4-dimensional array. Oh, it's actually saying it doesn't care about the value either. Oh, didn't realise that. Okay. Yeah, that's not trying to change the type on that one. The vertex attribute pointer. Remember before I was talking about the attribute. So it points to this, and that's how many items there are, which I think was 3. 6 divided by 2 is 3. The floats, and that's some other. These are to do with offsets. You don't need to worry about those just yet. That's the background colour we're going to set it to. Then we actually clear it. So it then clears it to that colour, which is RGB1, so RG, half green, so it's pale. It's a dark green colour. Then we take to draw the arrays as triangles rather, that number of items. So we're just going to take those 3 items and draw them as a triangle. If there were 6 items, it would draw 2 triangles.
What's the last bit? You've got 1 there. Because you have RGB and then have
A,
one value.
which is the
Transparency.
Thank you, alpha. Thank you. That's the word I was thinking. I was thinking the other day. What does the A stand for? I've completely forgotten. Alpha. Yes, that's what I am. So yeah, and all that gives you a triangle, which in and of itself is a bit dull, but it does get better. Well, by the way, WebGLworkshop.com is the website. My website for all this sort of stuff. So you go there, all the examples are there. Right. So with a bit more effort, you get a nice little coloured cube. Yeah. Dice, if you do a bit of texturing. These are just examples. I don't have time to run through them all. Right, so yeah, a bit more complicated. We have some more cubes or a teapot. Glyphs. Glyphs are nice and easy. It's a pain in the backside, excuse my language, with OpenGL to do any sort of text in a special library, whatever. One of the nice things about JavaScript is you can just do it to a 2D canvas, grab that as a texture, bang it on the screen, and away you go. So you can do labels and glyphs really nicely.
So the manipulation there, once you draw the scene, the manipulation you can do it through WebGL.
No, I'm doing it through JavaScript and then passing, what I'm doing, I'm grabbing the cursor position and then converting that to a rotation, which I then apply to a matrix. I then pass that into WebGL and it applies to the model and rotates everything.
All right. So
sorry, it's a bit more complicated.
It's a slightly longer program there.
Yeah. Yeah, I mean, it actually sounds more complicated than it is. I mean, once you get it up and running, the most difficult part is getting the click, I found, because you have to do an offset. With this canvas, might be offset slightly. So you have to do a calculation to get the click, start, begin, end. That's actually the more complicated bit. Once you've got that, applying the rotation, actually using a matrix library makes that easier. Once you've got that change in position, you convert that to a rotation and apply it. It's actually quite simple.
The compilation, do you do it on the fly?
No. The thing is, once it's compiled, you don't recompile. You just send a different value through. If you remember, hang on, back about page.
It's like a variable.
Yeah, it's a variable. So the compilation is not repeated. Once it's done, it's done. We don't need to repeat it unless we're going to change something fundamental, or we probably have a separate program. What happens is this value is changed. These values are changed. So we just send that through again. So there's no recompilation. It's only done once, and that's just sent through. Yep. Long lists. Anybody here know Hellraiser? We have such sites to show you. So I do that sometimes. People don't know what I'm talking about. They're so young these days. It's depressing. I'm getting old. Right, so that's it. Right, yes, so it may seem long-winded. It is, I must admit. But it does scale well. So once you do it, you don't need to worry about it again. So you do your first setup and you just reuse that code over and over again. There are utility libraries that take care of it all, or a boilerplate. So you write your own or use boilerplate. There's a Google libraries that are quite nice to take care of the basics. I find I extend it slightly more than that, but again, the boilerplate's quite easy to tackle. Right, as I mentioned before, GLSL is C-like, strongly typed. It's optimized for geometry, native support of vectors and matrices. So again, if you're used to a more traditional languages, you can have ints, floats, whatever. It also has matrices, so you have mat2, mat4. They're all square matrices, mat2, mat4, mat3. So there'll be square 3 by 3, 4 by 4. You have vectors. So rather than a C-block vector, which is like an array, this is a vector X, Y, Z. W, actually, because you have four-dimensional vectors if you want to as well. Geometry functions built in, so things like cosine, dot, cross, reflect are all part of it, of the language itself. They're not a separate library, so you don't prefix it with math. You just use them straight out of the box, and they will work. Dot and cross are vector functions for multiplying, also matrix functions you can use to multiply for anybody who's of a geometrical bent. Right, the thing called a swizzle. We're talking about vec3s, for example. So you have two vec3s, v1 and 2. You can access the members either using an array notation. So for vec 3, you can access 0, 1, and 2. You can also access the members with RGB, R, if you want to do so. Assign a single R in. They actually are equivalent. So that would be the first item. Or X, Y, Z, so you can actually apply all three at once, or any two, or four if it's four-dimensional. Or, for example, that. You can actually assign in any order X, Y, and Z equal to B, B, and B. You can't mix X and B, for example, but you can actually have them in any order otherwise. And you can actually, as long as within an accessor, you can't mix them, but you can actually sort of do it that way. Are we all happy with RGB and X, Y, Z as being obviously two-dimensional coordinates or the colour? You can also do it with textures, which I think is RS, P, and Q, or RS, T, and Q, I can't remember exactly. So you've also got the texture coordinate system as well, again, if you're familiar with coordinates. One of the things about WebGL is it only supports 2D textures, not 1D or 3D textures, unfortunately. That might not mean a lot to you, but if you do volumetric rendering, it's nice to have 3D textures. But again, that's a bit specialist niche, I think.
So how do you know which object you touched with your mouse?
Three ways. You can have a separate color map, so you can actually render it into colors, and you just look at the color under the mouse where you've clicked. So each object has a separate color assigned to it, so you can just look it up. That's good for about 256 cubed objects, which is about 78 million objects. Or you can actually do a thing called unproject. So you actually project a line through 3 space and compare that against all the objects within the scene. Again, there are libraries that do that. The color picking one's actually quite a simple one to implement, and usually works quite well. I've not actually done that code yet. I've just done the rotation. I think I did an editor where you selected from a drop-down menu rather than do a click.
No physics engine in there or anything.
No, that's actually raw WebGL I've just written. I'm going to get to engines in a minute. If you use something like Babylon, that's got a built-in engine. 3GS, I can't remember which engine it tends to use now. Canon. 3GS tends to use it's optimized to use a particular graphic 3D physics engine, but you can use others if you want to. You can actually mix and match. I wrote a game using 3GS and a 2D, I think it was Bullet.js. So I was actually using a 3D game, but it was using 2D physics. Right, so moving on. WebGL's markup. If the coding aspect makes your brain squeak, and you might want to prefer using markup, so it's just like web design. There are 3 that I know of: GLAM, jQuery 3, and X3 DOM. I'll just run through quickly some code. Come on, shrink. I'm sorry if I'm jumping between the resolution. It's the resolution in this projector isn't quite what I expected. Right, so if you're using GLAM, you would include the library. And then it's where are we? Is it include there? Yeah. So that's your CSS, effectively. Some variations, obviously. You've got a URL there for all your shaders. This is where you get your shaders from. So you drag your shaders the same way I did. Vertex shader and a fragment shader. These are your textures. It also defines uniforms. So you've got a uniform for your time. Yeah. So F would be a float. T would be textures, and these are where your textures are kept. Keyframes for animation, and the animation in your Y, presumably. I'm not familiar with these, I just know they exist, I haven't really played around with them. Then you were going to do something in your JavaScript, so it's obviously not just pure web markup, you need to actually have some code in there. So you're just updating the so you've got a listener, so you do a load, some animation, and then your HTML. So you just got your GLAM tags, your scene tags, and it's a sphere which you're going to call sun, and that's your animation there, and it's just that's just a radius. Hopefully that's self-explanatory. There we are. I'm not going to give you that, but it looks pretty nice. This is an example on their website. I didn't write the shader for the sun, but it does look pretty cool in my opinion. So it gives you some idea what you can actually do with shaders, rather than my simple examples. This is jQuery 3, no code I'm afraid. That's just a sphere with texture on it, so you've got the Earth rotating. X3 DOM is much more like proper DOM, I think. So you've got your X3D tags, and then you're defining your scene within those tags. To me, it's pretty self-explanatory. So you've got a shape, you've got a material you're using it, and it's a box. You've got another shape here, which is a cone, another shape here, which is a sphere, and you've got different types of materials on each one. So you've got a red one, a green one, a blue one, and you've got one at position 1, position -3, and position 3.
They're all the same size, they're all standard, like 1 unit size or something.
I presume so, it's not my library. But I think so, yeah. It wouldn't make much sense if a cube of 1 was 10 times the size of a sphere of 1. So I'm assuming 1 is the standard unit within the model. And that's the result of that. The nice thing about this is it actually has the key interaction built in. There's no extra coding to put there. I think it's quite natty actually. If you just want to, you don't want to be concerned with actual coding. Oh, lost focus. Page down. Work. Come on, thank you. Yeah, lots of APIs out there. It seems like every time I look around, there's some more. I might have discovered a couple more today, which I hadn't heard of before. Two of the best known are probably 3JS and Babylon.JS. Both have plenty of support, big communities, online editors of varying utility. 3JS can be a bit unstable. If you're using a CDN, or if you just get the latest version and start working with it, you might find your code's broken. They changed cube to box, for example. That wasn't much fun. Broke all your code. And then they have a thing called geometry. There's a geometry file, and they changed one of the variables within that. It became obsolete, so the code crashed. And it was commenting it out, but it was a pain. That's some 3GS. You can see it's much more concise, and you get a lot more out of it. So that actually defines a cube and a texture, box geometry, basic material. Bam, there you are. It's quite nice, and you've got an animation loop here as well. I presume we're all happy with the request animation frame. That's standard JavaScript now. So it's just updating it, and you get in your box. You crate. That's what it's called. It's crate. Yes. Right, Babylon.JS. Very similar. The requirements are a bit different. I don't know why, but when you create an object, for example, you have to give it a name, whereas in 3JS all the objects tend to be anonymous. You can give them names, but you don't have to. In Babylon, you do actually give them names. No actual output for that one, but I think that's essentially equivalent to the other one. Yep. Some more APIs. You've got Pixie.js, which is actually a two-dimensional rather than 3D. It's quite a nice one. Play Canvas is more of an editor, really, but you've also get the engine if you want to, so you can do your own coding. OA3D, which is, in some respects is a replacement for Flash. I believe the founder, Rob Bateman, no relation, works quite closely with Adobe, and it's intended for that purpose. XTK is a JavaScript implementation of ITK and VTK, which are image toolkit and visualization toolkit, which are commercial quality standard visualization tools. GLGL, I think, is a bit out of date, as is SpiderGL. CopyCube is a free version of a commercial package, and TWGL is a tiny WebGL helper library, which is essentially they call it boilerplate, but I find it a bit fiddly, and many, many more. That's another example. Online editors, Play Canvas and Goo, or Goo Create, are actual online editors for writing games. I don't know if anyone here has used Unity, but essentially like Unity, but in the browser. So you can actually write a game and publish it online. They're commercial. You can have free accounts, but they are commercial as well. So they're hosted on their servers, so people can't hack your code. We have modeling tools, 3D10, Claro.io, WebGL Studio, but again, like Blender, but again in the browser. APIs with online 3D editors, 3JS and Babylon. They both have their own editors that are quite nice. Babylon.js particularly is quite nicely developed. 3JS is improving. Right, Unity, you can actually use that to develop WebGL if you want to, because you can actually export to WebGL. Adobe Animate CC, which I know next to nothing about it, it's relatively recent. Obviously, since Flash is dying a death, they are actually moving towards WebGL, and you actually export your Flash your Flash presentation as WebGL. That's all I know. Again, online editors. Now these are specific to just two-dimensional editors. So if you want to do shading or procedural textures, things like that, these are very useful editors to use. They also have a lot of examples online, some of which are absolutely mind-bending. The stuff they can do within a couple of hundred lines of code within the shader is actually quite amazing. Right, various techniques. Let's have a look. So, as I said before, it's just a renderer, but you can do all sorts of wonderful things with it. So, you could actually, if you wanted to, add a teapot to your web page. Oops, where are we? I think there we go. This one's quite interesting. It takes a little while to run, and so does this one. Right, just going to show that. So yeah, so you can just decorate web pages. That seems to be the favourite at the moment. 2D to 3D rendering, as I said. Image processing. So you can actually have, if you have an image on your website, the users can actually interact with it, so they can do things like edge detection, filtering, sepia tones, and so on and so forth. Volumetric rendering I'll show in a second. ISO surfaces. Again, that's to do with medical imaging. So you might have a 3D scan and you want to see the heart as a surface. You can actually do that. Point cloud I'll show in a second. GPU. When I was showing you the Mandelbrot set earlier, that was essentially GPU. That's general purpose program on the GPU. It was calculating the actual Mandelbrot set on the GPU. The nice thing about that particular set is that you can do it for each pixel independently. So it's what's called embarrassingly parallelized. So it's really easy for all the cores on the GPU to do that. So it's really easy to split it out over the
Was that
GPU.
in a dedicated compute shader, or was it just in
No,
the
not a compute shader at all. Unfortunately, you don't get compute shaders with WebGL. The only shaders you get are the vertex shader and the fragment shader. You don't get compute. You don't get geometry or tessellation. No, that's it. And I hate that actually. I would love to be able to have some geometry shaders.
Yeah.
Sorry. Not yet. Not on WebGL 2 either. Looking at things like instancing, and possibly, I think they might be doing something with textures, but I'm not sure about that. But again, it's all done in the pipeline. So let's have a look. What have we got? Right one. Oh. This is a better 3D rendering, volumetric rendering, before we do that. Oh, this one's good, yeah. This is La Familia Sagrada in Barcelona. This is actually just point rendering. If you zoom in, you can actually see the points, and then it's, yeah. So this is actually done with a laser, I believe. So you have a laser scan of a real object in real time. So a heck of a lot of points there to be. In fact, it's still loading that many points. So I can actually move around. So if you wanted to, you could go downstairs and look at the shops down there. I've actually been here, and there's actually quite a nice shop just along this road here, quite a nice souvenir shop. There was a program recently where they'd done something similar with Rome, above ground and in the catacombs. So you can actually see a composite view of above and below ground, and it was amazing. It looked really cool. So this is the sort of stuff you can do in the browser. This is in the browser. This is not an app. It's not something you download. It's not something you install. You just browse to a page. Pow, it's there, and it looks good. The building? La Barba. So there's no. Sorry. Oh, that one. Sorry. No, I do apologise. Let me see. Where are we? 12, 11. There we go. Oh, sorry. That one is. That one's in beta server. If you just do a search of point cloud WebGL, that should come up with that one. Sorry. That's the Sagrada Familia in Barcelona. All right, this is actually 3D rendering of a bonsai. So they stuck a bonsai in a CT scanner by the looks of it. So this is a 3D volumetric rendering, which is a pain in the rear end to do in WebGL, unfortunately. But you could actually do this with a heart or a rib cage or something else. I was working on a project with dosimetry a while ago, which was cancer treatment to give somebody a dose of chemicals, and they want to see where it is, so they do a scan, and then they can actually reconstruct in 3D where the chemo was actually going. It can also be used for web VR. Google, I'm pretty sure, if you well, again, that's online, and it is web VR. If you've got quite a few examples, if you've got Google Cardboard, you can select Google Cardboard, and you've got your 3D VR experience. So applications, it's used a lot in games, which I won't go into at the moment. There is one called Tanks, which is a very nice one. Medical imaging was mentioned, data visualization, architecture. Fashion design, a couple of projects out there, which I haven't seen come to fruition yet, where they actually do modelling for clothes, the actual fabrics, how it falls onto a mannequin or a person. There are at least 2 companies I know that are actually looking into that, probably 3 or more. Mining visualization, whether the Met Office in this country is using WebGL. They're trying to do some visualization for clouds, big whoop, but also things like our systems, actual weather, the weather itself. So that would be an interactive application where you could actually see what the weather's doing in 3D in real time. Things like isoclines and things like that. Dinosaurs with lasers. Yeah, I know a guy who works for the British Museum. They actually have scans of, he couldn't give me an actual interactive example, but they actually have kiosks at the museum where you can actually interact with the 3D scans of the dinosaurs, or in this case of hominin remains, fossil finds. Some resources where you can go to get 3D models. Yobi 3D is quite good. I think it's been described as 3D Google for models. It can be a bit tricky to actually find somewhere to download the model, but you can actually preview it in the website, which is quite nice actually. So you can actually interact with it in 3D and see what you want. That's done in WebGL. Sketchfab, that's built on WebGL as well. That's model hosting embedding. That's quite nice. If you use something like AutoCAD 123D, you can actually take a series of pictures of an object, build up a 3D model, and then host it on this. And if you want to, put it on your Facebook page. I did that with a few months ago. Actually, all I did was, the only thing I had to hand was a Lucozade bottle, so I did that as an example. I only did about 9 images to actually get it. It wasn't a particularly good model, but you can do it in quite low resolution. All right, that's it. Hopefully I haven't confused you too much. Contact details, you're quite welcome to drop me a line, carl.bateman@webglworkshop.com. As I say, webglworkshop.com is also a host for my everything to do with the workshop and various bits and pieces. Follow me on Twitter at Carl Bateman. So thank you, and any questions?
We can, if you would like to create a scene, we can use raw WebGL and write the shadows ourselves, or we can use libraries. And looks like for practical applications, libraries is the way to go because you can make things quickly.
Somebody once said that if you want to get Rudewood done, use 3GS, and I'm inclined to agree. So if you, depending what you're doing, I would recommend using an API, something like 3GS, Babylon, and there's one called Scene.js as well.
So in this case, apart from experimental things, what would be the practical application of the raw WebGL without any APIs?
Raw WebGL, some people like it for its purity. One of the things with 3GS, if you want to do something specific and it doesn't do it, you're up the creek without a paddle. And it can be very difficult to force it to do what you want it to do. So you have to know the WebGL yourself to go back to it. If you do the WebGL yourself, the download is going to be a lot smaller. I think 3GS is about 500k. If you do raw WebGL, it's going to be a much smaller, 50k, 10k, I don't know, maybe less, depending on what you're doing. More flexible, and you have a better understanding of what you're doing. I mean, you can get as far away from it as you want to. You can do raw WebGL. You can use an API like 3GS, for example, or use DOM or use something like Play Canvas or Google Create, which is essentially modeling in the browser, and you had a few scripts, so you're almost completely removed from it then.
Yeah, but Google Create kind of really feels kind of like it's really editor. I met actually the creators of Google Create.
Well, there you are, you see. Well, the other thing is you have a choice. You're not forced to do one thing. It's been going, WebGL's been out there about 3-4 years now, and you've already got a huge choice of tools to do what you want to do. I think it might be a case of stuck it in C. You might want to do 3GS as a prototyping tool, or Babylon's prototyping tool. I do actually rather like Babylon. It's very active. It seems to have more shaders as well. A Play Canvas, again, as you said, it's in the browser, but the engine is open source, so you don't have to use the editor. You can just use the engine, underlying engine. You could possibly do a lot of development. Again, you could prototype in Play Canvas and then do your final stuff either using their engine or something else.
You have said that you have to test this WebGL on plenty devices, obviously because it's usage of power and battery. Do you know any devices that actually not supporting it, like or using the half of the battery in a couple of
As
minutes?
far as I'm aware, all devices support it. Memory consumption, I'm afraid, will be stuck it in C. There might be some official figures out there, but you always treat vendors' figures with a degree of skepticism because they tend to optimize for their device. I was trying to think of an example there. So yeah, it should be supported. It's just a case of running it. It's like anything you develop. I mean, one of the things I've learned when I started doing JavaScript development is you have to test it in all the browsers. It's funny because depending on the nightly build as well, some browsers change support and you can actually break from one version to the next. One of the interesting things about, in my opinion, about Microsoft is that Windows does not actually support WebGL directly. It actually compiles the WebGL to DirectX, which then runs in the browser. There is a switch that can force it to WebGL, but that becomes really weird because Windows only supports OpenGL 1.1, whereas WebGL is far more advanced. It actually has shaders. OpenGL doesn't have shaders. So you have this weird disconnect where the browser has better support for OpenGL, WebGL, than Windows does.
Yeah, but the opening interface that you can actually at some point use the actual shaders of the...
Yes. But if you're going to be doing OpenGL native on Windows anyway, you'd probably be using something like Glue or Glex, I think. So you'd be using extensions anyway. It's not really that difficult. It's just strange that you just use WebGL and straight away you got shaders. You don't have to worry about any extensions. You just go. It just works. You're welcome.